Hello everyone, welcome back to the videos. Today we're still in Unit 1 on Matter and Energy, and we're going to cover Section 8 and Section 9, which is classifying matter. So I know in Period 4 or 5 you already covered Section 8, but we didn't get to it in the other classes, so I'm just going to do that real quick. Section 8 is the definition of temperature, and you really want to make sure that you don't confuse temperature with heat. Temperature is not a measure of heat, it's a measure of how quickly the molecules are moving. So we say temperature is a measure of the average kinetic energy of the molecules in a given sample. Keep in mind it's an average. Okay, so we take the movements of the molecules, and typically you should know that if you're in the gas phase, you have more kinetic energy than you're in the solid phase. If you forgot what kinetic energy is, it's energy of motion. And really, all the motion of the particles depends upon is the temperature. So if you're at 100 degrees Celsius compared to 50 degrees Celsius, you'll have more kinetic energy at the higher temperature than you would at the lower the temperature. The hotter it is, the faster the molecules move. So the higher the temperature, the faster the motion of the molecules, okay? So at 100 degrees, we have more kinetic energy than we do at 50. Nothing else matters. When it also comes to temperature, you have to know that we use the Kelvin scale in chemistry. The abbreviation for Kelvin is K, not 0K. Celsius is degrees C, okay? So you have to know how to interconvert between them, and the equation that you need to do that is given in reference table T as in Thomas, okay? So I may have that up. I think I closed the window out. Yeah, I closed the window out. So just take a look at the back page of your reference tables, and you'll see the equation there for temperature conversions. The equation is that Kelvin temperature always equals the Celsius temperature plus 273. So if we're converting the 50 degrees Celsius up here, we'll just give you an example. If you have 50 degrees Celsius, to convert that to Kelvin, you would just take your 50 degrees Celsius and add 273 to it, okay? And if we add 50 to this, that's going to give us 323 Kelvin. So if it's 50 degrees Celsius outside, it's 323 Kelvin outside. I think it's a little warmer than that today. I can't wait to get outside. I think it's 70, okay? So we had that still to wrap up, and thank you 4 or 5 for being patient with me and allowing me to wrap that up. We've talked about measuring matter and changing matter and the phases of matter and observing matter, and now we have to take all the matter, anything with mass and volume in the universe, and convert it or dissociate it into different groups, classify it. We take it and we categorize it. So we take all the matter in the universe and we really break it down into 2 groups. That which is pure, which we refer to as a pure substance, and that which is not pure, which we refer to as a mixture. Okay, and we're going to talk a little bit more about each of these right now. So there are really 2 types of matter in all the universe, and you're going to want to write this down in your notes. There are mixtures and there are substances. Mixtures are impure, they're not pure. Okay, and I give you this little mixture of nuts here as an example of a mixture. Most matter that you encounter is a mixture, and that matter which is pure, which are substances. And in order to be a substance, you're either an element and found on the periodic table, or you're a compound. And we'll talk about the definitions of each of those and what those are. Okay? So let's talk about pure substances first. If you are pure substance, that means you're made of only one type of atom or molecule. You're made of only one type of matter. Every bit of the substance is the same. The substance has a uniform composition. And there's only one type of matter present. Sorry, I'm going up a little bit. along here. Okay? So when you look at water, okay, water only looks like one thing. There are only water molecules present in pure distilled water. When you look at, I have some magnesium ribbon here. When you look at this magnesium ribbon, all that this is composed of are magnesium atoms. It's pure. There's no other type of matter present. It's an element. Whoops. When you look at, this is some zinc, elemental zinc. Okay, when you look at zinc, there's only one type of atom present in the zinc, and those are zinc atoms. Okay? So, in pure substances, they are made of only either one type of atom, or if they're compounds, they're made of only one type of molecule. For example, I have some chromium chloride here. This is a compound. It's made of two different types of atoms, but they've bonded to make a molecule, and therefore they behave as a unit. So all you will find in here are chromium chloride molecules. Okay? So all pure substances are homogeneous. That's a new word for you. And homogeneous means that they look like only one thing. Okay, so even though this chromium chloride is made of two different elements, it only looks like one thing because they bond together and function as a unit. So they say it's homogeneous, or sometimes you'll hear it pronounced homogeneous. Okay, it's the same thing. If you are a pure substance, then you are either an element or you are a compound. And we're going to talk about the properties of each of those next. So elements first. Elements are the things on the periodic table, okay? They're found on the periodic table. There are something like 117 different elements. They just discovered a new one or created a new one the end of August. Okay? If they're not on the periodic table, they're not an element. And elements are the building blocks from which all other forms of matter are made. They are the simplest form of matter and cannot be broken down. Or the fancy word for broken down, decomposed. They cannot be decomposed. They cannot be broken down. They're as simple as it gets. The smallest unit of an element is called an atom. And all elements are composed of only one type of atom. For example, the magnesium that I just showed you, this is made of only magnesium atoms. And the zinc that I just showed you, well, that's made of only zinc atoms. And hydrogen's made of only hydrogen atoms. And oxygen's made of only oxygen atoms. There's only one type of atom present. It is an element. And it cannot be broken down any smaller. It's the simplest unit. We represent elements with a two-letter symbol or one letter. If it's a two-letter symbol, the first letter's capitalized and the second letter's lowercase. For example, that magnesium that I was showing you has a two-letter symbol. The first letter is capitalized, the second letter's lowercase, Mg, okay? These are homogeneous because they're made of only one type of atom. They only look like one thing, okay? And some common elements in their symbols, I'll just list a couple. I gave you magnesium, we'll list zinc, helium, carbon, oxygen, fluorine. There are a lot of elements. Again, I'm not going to list Fluorine. I'm not going to list all those elements, but just to give you an idea, those are a few. Okay? Simplest form of matter cannot be broken down. Next, whoops, not yet. We have the other type of pure matter, the compounds. And compounds, see that hard C? Compounds are chemical combinations of elements. compounds are chemical combinations of at least 2 or more different elements. So if you take elements and combine them and they react chemically, they make a compound. Now, I can try to combine this zinc right here with this magnesium. And I can put them in the same container. I need a container. Here. But they do not react chemically. They just chill out in the same container. Then it's not a compound. It's a mixture, okay? That's the difference. If there's a chemical reaction, you'll make a compound. If you don't and they're just chilling in the same container, that's a mixture. That's different. That's not pure. There's different types of atoms here, okay? Compounds have only one type of molecule present. They're pure. Since compounds are chemically combined, they can be chemically decomposed back into the elements that make them up. They have a fixed composition, and therefore they have formulas. For example, hydrogen and oxygen chemically combine to make water, and it's always in the same proportion. 2 hydrogens to 1 oxygen, okay? They're composed of bonded atoms that are called molecules, and they function as a unit. And as a result, since even though their water is made of hydrogen and oxygen, they act together as a whole new thing, and they're known as a molecule, and they're made of only one type of molecule. So even though there's hydrogen and oxygen, they don't behave separately. They behave as only one unit. So all water is made only of one type of molecule, which is water molecules. So they're always homogeneous. Okay, or homogeneous. Some common compounds for you are baking soda. You've probably cooked with that before, or at least heard of it. That's sodium hydrogen carbonate is the chemical name for that. That's a compound. So even though it's made of 1, 2, 3, 4 different types of atoms, they behave all as a unit to create one molecule. Sodium chloride, table salt, right? NaCl. You have water, H2O. You have carbon dioxide. We played with that the other day. That's CO2. You have carbon monoxide. That's CO. You have methane gas. That's CH4. You have sugar. Sucrose. C6H12O6. Those are all common examples of compounds, and there are many more that we'll talk about as this class goes on. Here are some others. You may have had milk of magnesia for an upset stomach. That's a compound. If you ever heard of saltpeter, sodium nitrate, that's a compound. There are many compounds. If your matter is impure, it's called a mixture. And mixtures can be classified based on their appearance. They are either homogeneous or heterogeneous. If the mixture looks like only one type of matter is present, we call it homogeneous. Kool-Aid is an example of that. There's water, there's sugar, there's flavorings, but it only looks like one thing. It only looks like colored water, okay? Powerade. These bubbles, I have some bubbles over here. It's a mixture, soap and water and other things, but it only looks like one thing. It's homogeneous, okay? Matter that looks like more than one type is known as heterogeneous. And examples of heterogeneous mixed matter are oil and water, or soil. That when I had the zinc and the magnesium mixed together. Okay? Those are examples of heterogeneous compounds. We're going to pause here, and we're going to have to continue this in a part 2 video. So I'll stop this one, and then we'll pick up in part 2.